Hi everyone, Mrs. Bilo here. In this video, I'm going to go over how to do calculations using Dalton's law of partial pressure when a gas is collected over water. So for this question, it says carbon dioxide is collected over water at 25 degrees Celsius. The partial pressure of the carbon dioxide is 0.96 atm. What is the total atmospheric or barometric pressure of the container in ATM? So first thing is we are solving for the total pressure. So that's the same thing as saying like what is the overall pressure that apparatus is at. And it says that the partial pressure of the gas is 0.96 atm. Both of these are an ATM, which is good. Plus, and then we need the partial pressure of the water. Well, in the problem, we were given 25 degrees Celsius. So we can actually look on this chart here to determine what the pressure of the water vapor is. So if we look on the chart here, 25 degrees Celsius is 23.8 mmHg. Or 3.17 kPa. So we can pick either one of those. I'm going to go with mmHg. So that's 23.8 mmHg. However, the gas needs to be an ATM because both of these values, well, this one's already an ATM, and we need our answer in ATM. So we need the pressure of the water vapor to also be an ATM. So I'm going to go ahead and convert this into ATM. Remember that 760 mmHg equals 1 ATM. And you can always look that up on the equation sheet that you're provided. So I'm going to go ahead and do the math for that. So that's 0.0313 2 ATM. So I'm going to go ahead and plug that in here, 0.03132, and that's also an ATM. So I just have to add those two values together to find the total pressure in ATM. So I'm going to do plus 0.96. So my final answer would be 0.9913 ATM. And that would be my answer. Again, just like we talked about up here, you want to make sure that when whatever you're adding or subtracting, they are all in the same units for pressure. In this case, having everything in ATM was the easiest. Now we have our second problem. It says a sample of gas is collected over water at 30 degrees Celsius when the atmospheric barometric pressure is reading 0.98. What is the partial pressure of the dry gas in ATM? So this time we are actually being provided the total pressure, and that is in ATM. We're trying to solve for the pressure of the gas. That's what we're looking for. Plus, again, to find the pressure of the water vapor, we have to look on the chart. So we have 30 degrees Celsius. So 30 degrees Celsius would be 31.8 mmHg or 4.25 kPa. Just for the sake of the example, I'll go with kPa this time. So 4.25 kPa. And since we want the answer in ATM, and both these, we need this in ATM for our answer, and this is already in ATM, I would say the easiest thing is to also convert this into ATM. So remember that 101.325 kPa is equal to 1 ATM. So I'm going to go ahead and do the math for that. So 4.25 divided by 101.325 And again, I could have chose MMHG or KPA. It's whatever your preference is or whatever might be easiest to solve for the problem. And that is 0.4 or 0.04194 ATM. So I'm going to go ahead and plug that in here. Okay. So now in order to solve for the pressure of the gas, I would have to subtract that value from either side to get my final answer. So the pressure of the gas is going to be 0.98 minus that 0.0419. And so my final answer for the pressure of the gas is 0.9381 ATM. So again, whatever is easiest in terms of, I usually look at it and what can I convert the least, like what's the least amount of steps of converting so that everything is the same. In this case, it was easiest to convert the pressures for the water. It just depends on the problem in terms of what you want the answer in for the pressure. For the last problem, it says, what is the temperature of the water? So we got to work backwards here. So now we're looking for the temperature of the water, and we are given the total pressure in kPa, which is 105, is equal to, and it says the partial pressure of the gas is 85.07, and both of those are in kPa, which is good. Plus, we're going to be solving for the pressure of the water because we need to find that in order to find the temperature of the water. So in order to get this by itself, or pH2O, the pressure of the water, I have to subtract 85.07 from both sides, and both of these are already in kPa. So 105 minus 85.07. So that means that the pressure of the water is 19.3 kPa. So that means now I have to look on the chart for that pressure to see what the temperature of the water would be. So we're kind of working backwards here. So we're finding this, and then we have to look for this on the chart in order to find the temperature, or whatever's closest to it. So I have to make sure I'm looking in the column for kPa because those are the units we're in. And we have 19.3. So I would say the closest value is, let's see, 19.3 for kPa. I'd say the closest value is pretty much here, 19.93. I would say that's the closest. And that would be 60 degrees Celsius. So for an answer for this, we could say that it's about 60 degrees Celsius, and that would be an acceptable answer.